in front of you are the identities that we wrote on the board yesterday. Did you learn them?
No.
Not yet?
I wrote them down.
They're in my book.
A lot of them we've gone over, like the reciprocals and
You're exactly right. A lot of it.
all of the like sine minus x equals like negative sine x, like that I've got down. It's like the middle one. So
Okay, the middle ones, if you don't remember any of them today, remember that sine squared plus cosine squared equals 1. Remember that one. Okay, which is, got it? Make sure you remember that one. The others you will learn as we use them, but that one we're going to have to know pretty quick. The other ones, tan x is sine over cosine. Do you know that one? And what is cotangent x? Cosine over sine.
which makes sense.
But you're exactly right. If you know tangent is sine x over cosine x, all you do is flip them both over, right? So what we're going to do today is I'm going to give you what they call an expression. I'm going to give you an expression, and you are going to simplify it. Simplify it means combine everything that you can combine, reduce everything you can reduce, and in addition to simplifying it, you can have no fractions in your answer. Everybody knows what a fraction is, right?
Yes.
All right. So, we'll start with an easy one. All right. I have 10x times cosine squared x times secant x. Now, I've done these for like millions of years, so I can get the answer just like that. But I understand that you can't. So my hint to you is, can I cancel anything out? If not, can I change everything to sine and cosine? That's my hint to you. Is there anything here I can cancel out? Nothing cancels, does it? So can I change everything to sine and cosine? Using what we put on the board yesterday. That's all you're using. Now, tell me what I changed tangent to. Do you all agree? Okay. So I have sine x over cosine of x times, this is already there, so I'm going to leave it alone. What is secant? 1 over cosine.
So is it just sine?
Sine x.
Or sine x? Oh, okay.
Because look what happens. Do these two cosines cancel out with what's on top? Because when I have cosine squared x, isn't that understood to be over 1? And what is left?
Sine x.
Sine x. Make sense? That's what you're trying to do. That's our goal, is to get it. It's much simpler now. But the whole, and I know some of you thinking, when am I ever going to need this? This is, you will need this more than a lot of anything else you will need in this class, because what this is teaching you to do is to think differently. It's making your brain go a different way. That's the purpose of it. So that's why sometimes it's hard. Because sometimes we don't want to make that brain work harder. That is is hard. It is. You're making it think a different direction. But you know what? Who makes money in life? People that think. People that learn to think. So, is that okay? All right. This is a harder one. I have cosine theta over sine theta. Plus sine theta over 1 plus cosine theta. Okay. First thing I told you to do is see if something will cancel out. It will not. Agree? Second thing, change everything to sine and cosine. It already is. Do I have, remember, at the end, I want no fractions. Do I have two fractions? So I have to get a common denominator to get rid of them. Now, what's the easiest way to get a common denominator? Multiply the two together. So I'm going to multiply this times this. Would you agree? So my denominator is sine theta times 1 plus cosine theta. Everybody agree with that? Now, we practiced yesterday common denominators. What does this numerator right here become?
Oh no, it's there's two different structures.
Cosine times 1 plus cosine? Okay. So I have cosine theta times 1 plus cosine theta. Right? What does this denominator become? No, you said it first. Because when I multiply, I'm not adding. Okay, everybody okay with that? Can I get rid of parentheses? So I have cosine theta plus cosine squared theta plus sine squared theta all over. So I'm going to leave parentheses in the bottom because remember, I want to get rid of the bottom, so I need it to be able to factor out.
How did you get cosine squared?
I took cosine times 1 and cosine times cosine. What's wrong, Sammy?
I was thinking, I don't know.
Does it make sense what I've done? Okay. Do you all see anything in that I can get rid of? No. No. What's cosine squared plus sine squared? 1.
Oh.
So on top, do I actually have cosine theta plus 1 over sine theta times 1 plus cosine theta? that right? Now what will cancel? Will cosine theta plus 1 on top and bottom cancel? Do you see that? And what do I have? I have what? I have 1 over sine theta, don't I?
Cosecant.
Cosecant theta.
Why couldn't you just cancel out 1 plus cosine from the very beginning?
Here?
Yes.
Well, I just put that in. If I cancel it out, I'm right back where I was.
You have to get the one times square theta plus pi square beta plus 1 equals 1. That's how. What was the one?
See, I multiplied this one.
Yeah. Yeah.
See, I just multiplied that in. I don't want to get rid of it again. I'll be right. Just go in a circle. Everybody okay with that one? That one was harder. That one was harder. I agree. We should do another one, shouldn't we?
Yeah. I think I'm getting it now.
Good.
Maybe.
One minus secant squared theta over tan theta minus tan theta secant theta. I can change everything to sine and cosine, but it's going to get ugly because it's going to put fractions and fractions in it. So I'm going to try to not do that. But that's one way to do it.
Minus 1. The 1 minus.
No, I don't know what the answer is. Honestly. Then, didn't we practice factoring yesterday? Isn't that what we did? So I would assume if we practiced factoring yesterday, we probably should use some of it today. So, will my numerator factor? I only want you to look at the numerator. Don't look at the denominator. Just look at the numerator. Will it factor? You're not sure. You think it will? Okay, let me ask you this. Is it something squared minus something squared in the numerator? Is it? So how would that factor?
1 minus secant theta and 1 plus secant.
1 minus secant theta, 1 plus secant theta. Do you all agree? With your mask on, it's hard for me to tell if you're agreeing or disagreeing. Everybody okay?
I think so.
It's hard. I can usually read your facial expressions, and it's hard with the mask on. Everybody okay with what I've done so far? Now, if I factored the top, surely I can factor the bottom. Right? How could I factor the bottom?
Just
Get rid of tan, okay? That puts a tan out here. And what does that leave?
1 minus secant theta.
1 minus secant theta.
Oh, that makes sense. I see where I'm thought they were like all each individual things, but they're connected.
Yes.
Yeah. So I was like, oh.
What now? Is that right? Do I have a 1 minus secant on top and a 1 minus secant on bottom?
Yeah.
Well, at least that got it simple. So now what I have is 1 plus secant theta over tan theta. Right? Now I'm going to do some magic math. You all know this magic math. You just may not remember it. All right? But if I have a fraction, like this fraction right here, I can separate it into two fractions. The two fractions are 1 over tan theta plus secant theta over tan theta. Do you agree?
I don't know. Not really.
Okay, if I had 2/3 plus 1/3, is that 3/3?
Yeah.
Is it actually 2 plus 1 over 3? So all of these are the same thing. I can, when I have fractions, as long as they have one denominator, I just took this and put it in this form. I went backwards, basically. Did that help?
Yeah.
I still don't really understand how did you get 1 minus secant in the denominator there?
Here,
Yeah.
because I went to this right here,
Yeah.
and I factored out a tan. Tan divided by tan is 1. Tan secant divided by tan is secant. Basically, if I distributed this in here, I would get this. So I went backwards on distribution. Does that make a little more sense?
Yes, I think so, but then don't you have to later multiply tan back in?
If I don't cancel it out, I do.
Yeah.
But this canceled out. So I got rid of that. All right, so now we're here. We're close. What, I can get rid of the fraction with this one. What is it? Cotangent theta. Now, how am I going to get rid of this?
Multiply it by tan.
I can't multiply because I don't have a equal sign.
Yes.
Can I now change to sine and cosine?
Yeah.
What's the top?
1 over cosine.
1 over cosine.
So is it just sine?
What's the bottom?
Sine over cosine.
Right?
Over
So it's just sine.
1 over sine.
Thank you. Because my cosines cancel, don't they?
Yeah.
So now I have cotangent of theta plus 1 over sine of theta. Wow, I am close. I have one more fraction to get rid of. What is it going to become? Cosecant theta. Did you follow that? Does it make your brain hurt to think that hard?
Yes.
You just have to, like you said, you have to multiply side by side.
You do. And that's why we're doing this.